Okay, good morning. Welcome to
FamilyMath226a.
FamilyMath226a. So you were doing some old AMC problems today just for practice, and this problem gave you a real hard time, right? You looked at it once and didn't know how to do it, looked at it twice, didn't know how to do it. But when I saw it today, when I got home, it's actually a really neat problem. So it's from the 2006 AMC 10B, problem number 11. And it says find the tens digit of 7 factorial plus 8 factorial plus 9 factorial plus 10 factorial all the way up to 2006 factorial. Alright, so, first of all, do you understand the problem?
Yep.
Do you understand it?
Yep.
Alright, I thought you'd be interested in this problem tonight too, so. Look like an interesting problem?
Yep.
What do you think? What do you notice about it? What's different about this? Or do you have any thoughts about it?
Well, maybe to do it, maybe we could. Well, since this seems like a big sum, there must be an easy way to do it.
Yeah, that's a good thing on these tests. But, like, do you think you have to calculate 2006 factorial?
Probably not.
No.
Probably not, right?
So I have an idea.
You have an idea? Okay, great. What is it?
We could factor out a 7 factorial out of every term.
Oh, that's interesting. Actually, we could
And then
factor out.
multiply it by that at the end.
Yeah, that is still. That's not a bad idea. That is still going to leave us evaluating 8 plus 9 times 8 plus 10 times 9 times 8 all the way up. So that's going to leave us with some pretty tricky arithmetic to do.
Yeah.
So not a bad idea, but I think that will involve a lot of arithmetic, and we're going to try to find something easier. What other thoughts do you have about this? Does this remind you of any other kinds of problems?
Well, finding the units digit is easy.
Okay. Finding the units digit is easy. Why is that?
Well, in this case, you have a 2 and a 5. You have a 2 and a 5 in every term.
Okay.
Which means that the units digit is going to be 0.
Aha. Aha, the units digit is going to be 0. Do you understand why?
Well, yeah, because if you have a 2 and a 5, then the 2 and a 5 will go it's going to make a 10. And 10 times anything will end in a 0.
So here's 7 factorial, right?
Yeah.
So it has a 2 and a 5 in it, which makes a 10.
Yep.
And so the fact that there's a 10 in here tells us that the units digit of 7 factorial is 0. Okay, good.
But
And also, the units digit of 8 factorial is 0.
Yeah, you still have a 2 and a 5.
Because you always have a 2 and a 5.
that means the units digit of the sum is going to be 0.
Very good. That means the units digit of the sum is going to be 0. Okay?
Yep.
That is a great observation and really helpful in going to the next step.
Yep.
All right? So, what's the next step?
Well, I know the tens digit comes from the units digit and the tens digits.
Okay? That's right. When you're looking for the units digit of a number, all you have to do is worry about the units digit.
Yeah.
And that's because when we think about numbers in base 10, I'll draw a 3-digit number like, I don't know, 314. Okay? This is 3 times 100 plus 1 times 10 plus 4. So if I'm just looking at the units digit only, and I do whatever I want to this number, I square it and that's what the units digit is, or I multiply it by some other integers, I guess not whatever I want. If I take the square root, I got something else. But if I multiply it by other integers, I just have to only look at the last digits.
Yeah.
But it's not so simple for the tens digit, because the tens digit can come from both the tens digit and from the units digit. Okay, so that's a little more complicated, but maybe not super extra complicated.
Well, we could. I think I can figure out how much of the units digit, what the units digit part of the tens digit would be.
Not sure.
Because
I know what you mean.
Because the tens digit itself is what the units digit gives to it plus what the tens digit gives to it.
Okay. Well, we've already figured out that the units digit is 0 on all of these.
Yeah, but because you have a 10 and you're adding up a bunch of tens.
Okay.
So it's gonna carry over a few places.
Adding up all the tens.
Yeah.
It might. It might.
Well, we can figure out how many 10s we have.
Well, we have 2,000 tens. Because you've got 2,000 numbers.
Yeah, we've got
Everyone
2,000
has a
numbers
10.
we gotta add up. Any other ideas?
I'm running out of ideas.
Okay. Alright, I'm not gonna say anything, I'm just gonna turn the camera off and on and we'll go to part B and we'll try to come up with an idea.
Alright.
Okay?